This is a very standard problem. A lot of times you are expected to have such questions. Assignment status. నేను సార్ వాళ్ళు చెప్పింది ఏంటంటే ఇవాళ ఈవినింగ్ 1 అవర్ స్టడీ అవర్ వస్తుంది. రేపు 2 అవర్స్లో మేక్ షూర్ దట్ యూ కంప్లీట్ ఆల్ దీస్ 100 క్వశ్చన్స్ ప్లస్ మై నోట్స్. That's more than sufficient. Every week you try to please observe. They are not giving anything beyond this. Okay, we are not attempting for 18 by 18. In fact, at least 10 to 12 we can. Ashraf, correct hai na? Right. A uniform rod of mass m and length L is kept at a height h above of lower end at an angle theta. The rod is released from this position. The rod will collide with the smooth ground, which is elastic. This is a very important term. Elastic. Right. Angle and all that is given. Okay, fine. My intention is very clear. Your rod is like this and your floor is like this. We will name the ends as A, B. Please try to understand by the time the rod reaches this position. It will face an impulse. Before that, it will have some UCM. After the impulse, it may have VCM, along with which angular part will also come into picture. Just before and just after. Why the angular rotation is like this? Can someone please explain? Because about the center, the impulse is clockwise. So therefore, omega clockwise. Now, first of all, I know UCM is equal to root 2GH. I'll convert later on. And you said impulse J is MVCM minus MUCM. So clearly J is M times VCM plus UCM. Next. That's J. Clear. Let this be equation 1. Right. Also, about center of mass, apply angular impulse, angular momentum theorem, according to which, can you please help me in writing angular impulse now? Let this be theta. Anyone in the class? J into adera J into trial gedo. J is force kada, force into time. J into ఎలాగైతే టార్క్ వేస్తారో ఇక్కడ అంతే, ఫోర్స్ ఇంటూ ఫోర్స్ ఆర్మ్, L/2 cos theta. ఇది ఇంపల్స్, యాంగులార్ ఇంపల్స్. This is called angular impulse. And this is equal to what? This is equal to change in L final minus L initial. In fact, which point you are applying it is about the center of mass. You are applying this about the center of mass. So therefore, J times L/2 cos theta is about center of mass. Don't forget that. ml square by 12 omega minus 0. Equation 2. Because L initially is 0. Initially, it has a purely translational mass. What are unknowns? J is an unknown. Omega is an unknown. VCM is an unknown. So, sir, every time, whenever I am starting a problem, what am I exactly doing? Identifying the unknowns. That only allows me to write proper equation. So, already one equation I have written. Second equation I have written. I require one more equation. What is that? Elastic collusion means Bhavana చెప్పు కరెక్ట్ అప్పుడు ఏ పాయింట్కి అప్లై చేస్తారు ఈ పాయింట్కి అప్లై చేస్తారు జస్ట్ బిఫోర్ కొల్యూషన్ A is having UCM. Just after collusion, that's the deal. A. That's all. E is equal to 1 అంటే అర్థం ఏంటి L/2 ఒమేగా కాస్ తీటా నేను కరెక్ట్గా రాశానా ఒక్కళ్ళు కూడా కరెక్ట్గా చెప్పాల తప్పది ఇట్ ఈస్ రాంగ్ రిమెంబర్ that is wrong. Why I will explain. In fact, this is L/2 omega cos theta. This is L/2 omega. Now, if this is theta, this is theta. Because of which this is L/2 omega cos theta plus VCM. That is how you should understand. Whatever I have written initially is correct, but you need to know how the way I have written. Only vertical components is important. L/2 omega cos theta plus VCM is the same as UCM. Equation 3. Now, how many equations do you have? 3. How many unknowns do you have? 3. Solve it, you'll get the answer. Okay, and let us try to make it equation. So they have given a lot of values actually. They have given H value, they have given L value, they have given a theta value, all that. Say by solving all, why? Because the time is the constraint for me. By solving equation 1, equation 2, equation 3, you will get omega as 12 UCM. Don't forget what is UCM. Cos theta divided by L times 1 plus 3 cos square theta. Trust me, I have done. Right. Similarly, you will get J as 2 capital M UCM times 2 capital M UCM by 1 plus 3 cos square theta. Trust me, by substituting the given values, you will have 48 by 7 radian per second. By substituting this, you will get this as Newton second. 16 by 7 Newton second. Okay? Are you convinced? The nature of the problem is very simple. Please try to understand. They have actually asked x by 7, y by 7. Obviously, x is 48, y is 16. I got the same. Any doubts in this, boys and girls? Are we clear? Are you sure that you could do these problems? Right. Next. So I'm moving on to the next question. See this question. 3 identical uniform cylinders are mounted on a frictionless horizontal axles passing through their centers. They are given equal angular velocities, omega naught each, and then gradually brought into contact, preventing any vertical moment and rotation of their axles. Axles are fixed. Find the angular velocities of the cylinder after they just stop slipping. Right. Please try to understand in this question, in this particular question, once slipping starts, omega 1, see, on this friction acts like this, on this friction acts like this, on this friction acts like this, and on this friction acts like this. You may ask me, how do you know? Remember, at this point, the tendency of motion is upwards velocity. Now see, try to please understand, for this disk, this particular point, it will have a tendency of motion downwards. With respect to this point, it is having an upward motion. So friction acts downwards. So after sometimes VA, VB, VB, VC. You can see that this is rotating like this. After, see, after some steady state, what will happen is that this is an intermediate stage. In the steady state, you will have omega 1, omega 2, omega 3. I'm just assuming that that's the criteria. And friction becomes zero everywhere. Why, I will explain. Remember, now this point will have velocity v. This point will also have velocity v. This point will have velocity v. and this point will have velocity v. To avoid confusion, v final, v final, v final, v final. So clearly omega 1, omega 2, omega 3 is nothing but v final by r. That is one important observation. Now this is a final state. So please confirm, have you understood the migration from intermediate stage to final state? Yes or no? Clear? Next. Now you take for A, law of conservation of angular. No, you cannot apply this. Angular impulse, angular momentum equation to A. What you will get? Minus F into T into R is equal to, we will call this some omega dash, if agreed. I omega dash minus I omega, equation 1. Agreed? Boys and girls. Similarly, for B there are two such angular impulses. Minus 2FTR is equal to I omega dash minus, but for this the initial direction itself is different. Am I right or not? Initial, say, final is this. See, I'll explain. For example, why I took minus, I will explain. Clockwise impulse, I took minus. So anti-clockwise plus. Now, this is plus I omega dash minus the initial minus I omega, no? Equation 2. Right. So, so with this, I can use equation 1 and 2 to confirm I omega dash minus I omega into 2 is I omega dash plus I omega. This will become I omega dash is 3I omega. I think I am wrong somewhere. No. 1 minute. Just let me just apply steps properly. First step is very clear. First step is very clear. 1 minute. 1 minute. We will take clockwise negative, anti-clockwise positive. So on the first impulse is clockwise. Correct kada? Minus FTR is I omega dash minus I omega. Equation 1. Agreed? Agreed for A. For B, what type of frictions are they? Clockwise, Malli. Minus 2FTR is, what is final? Anti-clockwise. అంతేగా ఇది అరే ఫైనల్ ఇది ఎలా వచ్చిందో చెప్పాలి కదా మీరు. క్లాక్ వైజ్ యాంటీ క్లాక్ వైజ్ ఫైనల్ ఒమేగా యాంటీ క్లాక్ వైజ్ చూడండి మీరు. ఫైనల్ ఒమేగా యాంటీ క్లాక్ వైజ్ minus I omega dash minus initial anti-clockwise I omega. Now you please confirm me, have you understood this or not? 1 and 2 use change. By using 1 and 2, what you will get? 1 and 2. Uh, uh, right, 2 times I omega dash minus 2I omega is minus I omega dash I omega. So this will become I omega dash is equal to 3. ఎక్కడంటావు ఏ స్టెప్? సెకండ్ ఈక్వేషన్ లో ఎక్కడ మిస్ అయింది? యాంటీ క్లాక్ వైజ్ డైరెక్షన్ పాజిటివ్. ఇదిగో వేసానుగా. నేను కరెక్టే వేశాను కదమ్మా. మైనస్ ఐ ఒమేగా డాష్ మైనస్ ఐ ఒమేగా కరెక్టే కదా అది. అదే ఈ రెండు చేస్తే అదే వస్తుందా? సో వాట్ యు ఆర్ గెటింగ్ ఇస్ ఫ్రమ్ 1 and 2 3I omega dash is equal to I omega. So omega dash is omega by 3. Can you apply the conservation of angular momentum to this situation? Can we apply? We cannot apply. Why? There is an external force. Because there is an external torque. In the form of hinge force. You choose any point. If you are in this hinge, the other two hinges will exert force. So you cannot cancel torques. So therefore, you cannot apply law of conservation of angular momentum for this case. Now tell me, do you have any doubts in this? ఒక్క నిమిషం ఆగు. ఈ హింజ్ నుంచి యాక్సెస్, ఈ హింజ్ యాక్సెస్ నుంచి పాస్ అవుతుంది. బట్ వాట్ అబౌట్ దిస్ హింజ్? అబౌట్ దిస్ పాయింట్, దిస్ హింజ్ ఫోర్స్ will contribute torque. Right. ఇది చూడండి ఫస్ట్. Nice cube of mass capital M and with sides of either dimensions given with friction across a counter loop with a speed V0 when it hits a ridge. See what is happening at the ridge, I will explain. Next. Okay, na? Now what is happening over here? This is initial and this is say final. So now what I am applying is law of conservation of angular momentum just before and just after collision. Try to please understand what is happening initially is this is some VCM and this is A by 2. L initial is simply MVCM A by 2. So what is L final? It is a pure rotation about O thereafter. When this is a pure rotation about O, I can simply write taking, see, I know the moment of inertia about this is 2 by 3 MA square. Marchipera apde? No. So 2 by 3 MA square omega. Omega is equal to 3 by 4 VCM by A. Right. This is omega immediately after collision. Now what happens is total rotational KE in initial is equal to final. Okay, half total energy final. 2 by 3 MA square omega square is M. It's purely potential at that time. Andega? See, please try to understand. See, total diagonal height is this is total diagonal height is root 2a, out of which center of mass height is a by root 2. That's all. So solving this, you will get equation 2. So m by 3 a square omega square. Omega square is 3 square by 4 square. VCM square by a square plus mg a by 2 is mg a by root 2. M cancel, M cancel, M cancel. A square cancel. 3, 3 cancel. So finally, VCM square is, okay, 16 by 3 times G times A by root 2 minus A by 2. So VCM is under root of 16 by 3 G times A by root 2 minus A by 2. By solving which you will get 1.1 h. Okay. So basically the concept, what you need to understand is just before, just after you can apply law of conservation of angular momentum. Any doubt in this question, ask me right now. At any level of concept, if you have doubt, please ask me right now. Next. This is also a standard problem, actually. This is also a standard problem. Okay. 1, 2. I don't deal this question totally because you have, what do you call, the answer for, already I have done this question. Right. A brilliant ball of mass m, radius r, initially at rest, is given a sharp horizontal impulse by a q. The q is held horizontally at a distance h above the center line as shown in the figure. The ball leaves the q with a speed v naught. And because of its forward English, forward motion or something, Sanskrit eventually acquires a final speed of 9/7 V naught, calculate H. Right. Now see, here friction has nothing to do. So the moment you give impulse, there won't be any friction impulse here. J into H is ICM omega, equation 1. This you will say that angular impulse theorem. Please ask me if you have any doubt in the very first step. Boys and girls, do you have any doubt in this? Next, you have given impulse and hence it got a velocity mv naught. Right. Now, because of which what is happening? Now you take equation 1 by equation 2, avoid h, z. So h is, it is a brilliant ball. 2/5 mr square omega by mv naught. Cancel. So wherever I have v naught h, I can write 2/5 r square. Right, done. Now eventually it acquires a final speed. Matlab kya hai? Now remember, this is the initial situation for you. This is the initial situation for you, where this one is having velocity v naught, where eventually the speed becomes 9/7 v naught, and to avoid confusion, I will write omega naught, and it has some omega. Definitely just after impulse, pure rolling starts. So now I can apply law of conservation of linear momentum about a point attached to O. Yes or no? Law of conservation of angular momentum. So initially, It is simply m v naught r. Finally, it is about this point m 9 by 7 v naught r plus ICM omega. M V naught R is M 9 by 7 V naught R. No. 1 minute. Initially, it has omega also. I forgot that point. Initially, it has omega also, no? Plus ICM omega naught. Initially. Okay, right. No issues. And one more important point here, pure rolling is also happening. So MV naught R 2 by 5 mr square omega naught is m 9 by 7 v naught r plus 2 by 5 mr square omega. Hold on. There is no confusion in this. See, here v naught is r omega. Yes or no? Therefore, I can write 2 by 5 mr square omega naught is equal to this minus that 9 minus 7 2 by 7 mv naught r plus 2 by 5 m rv naught. Agreed, boys? 2 by 5 mr square omega naught is 10, 14, 24 by 35 mv naught r. M cancel, r cancel. So finally, omega naught or r omega naught is clearly, boys and girls, r omega naught is clearly 12 by 7 v naught. Let this be equation 2. Already done. Equation 4. Equation 3. Any doubts? Now use equation 4 and equation 3. V naught H is 2 by 5 R times R omega naught. 12 by 7 V naught. Cancel. H is 24 by 35 R. Please confirm whether you have any doubts in this. Actually got 4 by 5 which it. Yeah. Where I went wrong? Just please confirm. Just please confirm. We have done one mistake here. What is that is 9 by 7. 9 by 7 V naught is R omega. So this is a wrong substitution. Concept is right, substitution is wrong. Okay, no issues. Since we have identified that this is the mistake, that we can correct it. So mv naught r plus 2 by 5 mr square omega naught pure rolling. This is equal to, please convey me. 9 by 7 V naught mr square omega. This is 7 by 5 times mr square omega. Hold on, no issues. So mv naught r plus 2 by 5 mr square omega naught is 7 by 5 mr times r omega is 9 by 7 V naught. Here we went wrong. So therefore, mv naught r or 2 by 5 mr square omega naught is 9 by 5 minus 1 time mv naught r. M cancel, r cancel. So r omega naught is Kanisha 4 by 5 ante 2V naught. Antena? Boys and girls. No, this is your equation 4. Now therefore, ఇక్కడ కూడా ఒమేగా నాట్ అది ఒకసారి కన్ఫర్మ్ చేయాలి మీరు. వై 5, దిస్ 5 and that 5 gets cancelled కదా. So V naught H is 2 by 5 R times R omega naught is 2V naught. V naught cancel. H is equal to 4 by 5 R. Now my answer is absolutely correct. I am repeating where I have done mistake. I have done mistake in this step earlier, not now. As simply, V at that instant is 9 by 7 V naught. V is equal to R omega, correct. Which V? 9 by 7 V naught. Please confirm, are you thorough with these models? Yes or no? Paka? Sure? Right. I am not repeating this. This is also a very famous model. Very famous model. Make sure you go through this. There is the question, it seems to be incomplete actually here. Smooth horizontal surface. Before impact, center of mass of ball has velocity V naught and angular velocity omega naught as shown in figure. Right. The normal velocity is reversed with the same magnitude and the ball starts rotating after impact. Find the distance of the plank between first two impacts of the ball. Okay, fine, no issues. You imagine a long plank. Now start from the ball point of view. This is a ball. This is a ball. Angular velocity omega naught. After the impact, velocity V naught. Just set, you set the same V naught. And omega naught omega 0. And see, please try to understand, there will definitely be a horizontal velocity Vx for this. While I'll explain. This is some normal impulse, J normal. During the same time, this will experience mu Jn, friction impulse, not friction force, friction impulse. Because of which, immediately after, just before collision, that is the picture. Please give me a clarity that have you understood this? You may question me, you are cheating us. How do you know that there is Vx? Normally, anyone in the class, can you explain how do I know that there is Vx? No. How do you know that there is a frictional impulse? Okay, fine. No. మీరు కరెక్ట్ పాయింట్ చెప్పాల అదిరా ఆవిడ నా వారసుడు వాడు అలా ఆలోచించాలి. ఒమేగా నాట్ జీరో ఎలా అవుతుంది చెప్పండి? దేర్ షుడ్ బి సమ్ యాంగులర్ ఇంపల్స్ ఫర్ దట్. ఒమేగా నాట్ జీరో కావాలి అంటే దేర్ షుడ్ బి సమ్ యాంగులర్ ఇంపల్స్. సో దట్ ఈస్ డన్ బై ద ఫ్రిక్షన్ ఇంపల్స్. అట్లా ఆలోచించాలి. సో మాకు ఇది స్ట్రైట్ కాదు సార్ అంటే సోషల్ స్టడీస్ ఇంగ్లీష్ చదివినట్టు ఫిజిక్స్ చదివితే ఎలా వస్తాయి? తేజస్విని ఆబ్సెంట్ ఇవాళ వచ్చా కనిపించలేదు నేను, వాళ్ళిద్దరి మధ్యలో దాక్కున్నాను. ఇంకో అమ్మాయి నీ వెనక ఇంకో అమ్మాయి ఉంటుంది, అమ్మాయి ఆబ్సెంట్. వీణా రైట్. నెక్స్ట్. దిస్ ఇస్ V Planck. అంతేగా, బికాస్ దిస్ ఇస్ యాక్షన్ రియాక్షన్, యాక్షన్ రియాక్షన్. ఫ్రీ బాడీ diagram of Planck after impulse. Okay, right? What you need to apply is, first we will take x-axis as the criteria. How do I take x-axis as the criteria? If I take x-axis as the criteria, sigma px is yeah. నీకు ఎందుకే ఏ నెంబర్ దొరక్క మాకు చేస్తారా? ఎందుకు మీకు? Sigma px is equal to 0 because there is no external force along x direction. Don't comment on mu Jn, man. Action, reaction, cancel. If I take Planck and sphere together as a system, there is no, which means spherical ball, mass small m, mvx, capital M V Planck. Equation 1. Now, please confirm, do you have any doubt in this? Sigma Py is equal to 0. Any doubt? Now sigma Py is equal to 0. ఎవరికి అప్లై చేస్తారు? For sphere. So what happens? Jn is, you said it reverses its direction. So Jn is 2mv0. Small m కదా. Any doubts? Next. ఇంకారా? Equation 2 అయింది. ఈ యాంగులర్ ఇంపల్స్ అది చెప్పండి. minus mu Jn r is equal to 0 minus ICM omega naught. Omega naught ఏనా? Right. So therefore mu Jn r is 2/5 mr square omega naught. Boys and girls, that's the deal. What are unknowns now? What are unknowns? Vx is an unknown. V Planck is an unknown. Jn is an unknown. Yes or no? These are the three unknowns. ఇంకేమైనా ఉన్నాయా నాకు తెలియకుండా? You have three equations. Now you solve three unknowns. How to now use 2 and 3. In this case, mu by 1 is equal to 2/5 m omega naught by 2m v naught, which means I have divided 3 with 2. So m cancel, 2 cancel. There is one more r. So v naught is r omega naught by 5 mu. Omega naught you have given the data. V naught correct అయినా ఎక్కడన్నా ఏనా V naught కి omega naught కి రిలేషన్ వచ్చేసింది. రైట్. మరి Vx MVP ఎట్లా వస్తుంది? Vx MVP ఎట్లా వస్తుంది? Vx ఎట్లా వస్తుంది? How do I get Vx? MVx is mu Jn. MVx is mu times Jn 2mv0. Vx is mu, I just know, r omega naught by 5v0 times 2v0. So Vx, wherever it is, I can write 2/5 r omega naught. If I know Vx, I can find Vp also. Okay. Vp is small m by capital M times 2/5 r omega naught. Right. Please confirm I have Vx, I have Vp, even I have Zn. That's all. But that is not the question. What is the question that they're asking is, find the distance on the plank between first two impacts of the ball is what they are telling. Now it is as same as, if I imagine that this is the plank, in the reference frame attached, you said that what is the velocity of the plank? What is the velocity of the spear? It is Vx plus V plank. And it is V naught. So it follows a projectile path. Now tell me what is Vx plus V plank? 2 by 5 R omega naught common 1 plus small m by capital M. Right, done. What is that I have done? I'll explain. You want range with respect to him. Andega? Range. Range with respect to observer. Two times Vy Vx multiply range formula play. What is the formula for range? 2 into vertical component of velocity, horizontal component of velocity by g. This is 2v naught by g times 2 by 5 r omega naught. అదేంటి మనవాడు అది రెండు ఓకే ఇవ్వాలని అంటే మనం 5 రోజులు మనకు అందరూ మనకి అటెండెన్స్ అవుతుంది సాటర్డే పిల్లలు ఆడాలి మొదటి పార్టీ ప్రసాద్ తీసుకోవాలి అవుతుంది సరే ఓకే రైట్ రైట్ 1 plus small m by capital M. Done. Don't look at me that this is all the data given by you only. You have given me V naught, you have given me R omega naught. Omega naught as well as V naught you have given. So I have answered everything as per your data. Now please confirm, have you understood this or not? A very famous model. Really, really very famous model. Please confirm. Anika, every step. Don't look at the length of the problem. See the concept involved. Last 3 days, I am teaching the same concept. Only one concept. Right. Let me just see anything else seriously required. Yes, I'll work on this. Uniform rod AC of length L and mass M is kept on a horizontal smooth plane. It is free to rotate and move. Means free axis. Free axis. Okay. A, you can see that this is some mass striking this. Collision is elastic after collision. Right. Very, very good question. And high probability is there to ask such questions. Right. Yellow, chalo. Now what is happening? Just before collision, this is the point B. It will have two components. Can you please help me writing those two components? If this is V, 4V by 5 along the rod and 3V by 5 normal to the rod just before collision. Just after collision, you said this is elastic. Don't forget that. The point B where collision took place. I am assuming just after the collision, let this have some Vy and this remains conserved 4V by 5. And that object is here. Don't forget that. And this one, center of mass C, will have velocity Vc besides omega. Please confirm. Have you understood the entire free body diagram? Okay. So such collisions, tell me list of the steps. Bhavana, first step. Conservation. Next step. About a point just below the center of the rod. Third condition. E is equal to 1. మీకేం అనిపించట్లేదా అన్ని క్వశ్చన్లు? Now, law of conservation of linear momentum along y direction. So masses, I think same. Both the mass m, length L, same mass m. So therefore, is equal to equation 1. Any doubts? ఎవరు చెప్పారు b by 0 అని? అలా చెప్పలేము. వస్తే ఓకే అప్పుడే వెళ్తాం కండిషన్. ఈజ్ ఈక్వల్ టు 1 కావాలి. 1 dimensional head on collision అది కరెక్ట్. ఇది 1 dimensional head on కాదు కదా. రైట్. ఒకవేళ సి ఫర్ ఎగ్జాంపుల్ అదే సిచ్యువేషన్ వస్తే ఓకే ఫైన్ అలానే చేద్దాం. రైట్. నెక్స్ట్ law of conservation of linear. So law of conservation of angular momentum about a point just below center of mass of a rod. What do you will get? Initial angular momentum m 3v by 5 L by 4 because you said this distance is L by 4. And why I am not writing 4v by 5 term? I've written only 3v by 5. Why I am not writing 4v by 5 term? That is passing through center of mass. That velocity component passing through center of mass. So RCM bar cross MVCM bar 0. This is easy. ఇప్పుడు ఇలా ఎందుకు క్వశ్చన్స్ వేస్తాను అంటే అది కాన్సెప్ట్ అక్కడ. అప్పుడు మీరు బుర్ర కొంచెం అలర్ట్గా వినాలి. అవి వినకపోతే ఇట్ ఈస్ యాజ్ సేమ్ యాజ్ సోషల్ స్టడీస్ ఆర్ ఇంగ్లీష్ పోయిటరీ. రైట్. ఎంబీసీ రైట్. అబౌట్ నో ఫైనల్లీ plus about the rod. equation 2. Now, coefficient of restitution is equal to 1 along normal. And final L by 4, because after collision, this point will have a velocity, rod point will have a velocity Vc plus L by 4 omega. Therefore, L by 4 omega plus Vc minus Vy is equal to 3V by 5. Relative velocity of separation, relative velocity of approach. What are unknowns in this? Vc unknown, omega unknown, Vy unknown. These are unknowns. So you have 3 equations. Now, how to handle this? One thing I can do, I can use equation 1 in equation 3. L by 4 omega plus Vc. Everywhere you have M, remove all. So in the place of Vy, you can write 3V by 5 minus Vc is equal to 3V by 5, which implies L by 4 omega plus 2Vc is 6V by 5, right? This is equation 4. Now use 2 and 4. 2 and 4. In 2 and 4, also again you can cancel M over here undoubtedly. You can write this as 3 by 20 VL is equal to By term. అది కూడా చేసేద్దామా సరే అప్పుడు ఏమవుతుంది 3V by 5 is equal to Vy plus L omega by 3. So 3V by 5 is Vy is 3V by 5 minus Vc plus L omega by 3. Cancel. L omega by 3 becomes Vc. Okay. Now with this, I can write L by 4 omega plus 2Vc. 2L omega by 3 is 6V by 5. 3 plus 8. 11 by 12 L omega is 6V by 5. So L omega is 6 into 12 by 55V. 60, 72 by 55V. Right. First option is correct. Now, you know very clearly every term here. Now, with this, you can write Vc is L omega by 3. అంతేగా L omega by 3 అంటే 24 by 55V. కరెక్టా రాంగా? రైట్. రైట్. ఏటమ్మా ఏమన్నా డౌట్ ఉందా? ఆప్షన్ సి ఇంపల్స్ ఇచ్చేయచ్చు అంటావా? రైట్. సో దేర్ ఫర్ ఇంపల్స్ J is MVC for rod. So 24 MV by 55. So kabatti C is correct. Right. So since you know omega, omega is 72 by 50t v by L. హాఫ్ రివల్యూషన్ ఎంత అన్నారు? సో ఫర్ హాఫ్ రివల్యూషన్ omega is pi by t, అంతేగా? ఒమేగా కాన్స్టెంట్ అమ్మా, డిస్ప్లేస్మెంట్ బై టైమ్. సో t is pi by omega. So velocity of center of mass into time is the displacement of center of mass. So VC 24 by 55 by V into pi by omega. ఒమేగాని ఫ్లిప్ చేయాలి ఇప్పుడు మీరు. 55L by 72 టైమ్స్ పై. ఇది క్యాన్సిల్. 24 ఏమైనా పోతుందా 72లో? మా 3 టైమ్స్ V ఇంటూ L పై ఏమా పై న్యూమరేటర్కి వెళ్తుందా? టీ 1 minute, ఒక్క నిమిషం. ఇక్కడ దాకా క్లియరే కదా? టైం అంటే ఒమేగా టీ, టైం వచ్చేసి డిస్ప్లేస్మెంట్ బై ఒమేగా. కాబట్టి పై ఇంటూ 55L by 72V. SCM is VC into T. 24 by 55V into pi into 55L by 72V. Cancel. ఇదన్నీ 3 టైమ్స్. సో ఇప్పుడు మీకు V కూడా క్యాన్సిల్. pi by 3L. ఓకేనా? కరెక్ట్. దిస్ ఇస్ a very, very famous question. Really famous question, this one. Okay. Next. I think one more question was left pending. I'm searching for that. This is the question. That's pending actually. Read the question carefully. A uniform stick with mass m and length L is initially at rest along the y-axis on a frictionless horizontal table as shown in the figure. An identical stick oriented in x direction is traveling with speed v in positive x direction. స్టిక్స్ వచ్చినప్పుడు మన సిస్టమ్ మొత్తం మారిపోతుంది. దేనిలో చేస్తాం మనం? ఇఫ్ ఇట్ ఈస్ స్టిక్స్ టు ది ప్రాబ్లం ఇన్ C frame. So what is the velocity of center of mass? Simply mv by 2m I cap, which is v by 2 I cap. Now for this system, That's the center of mass of the system. Location of center of mass of the system. Right. Now, in the reference frame of center of mass, I think I need to change the color. This one is moving with V by 2 velocity. Correct? Incorrect. Wrong. Velocity. V by 2 in this direction. And this is going with V by 2 in this direction. First of all, by the way, what is the moment of inertia of this rod about this point? Remember, this is L by 2. కాబట్టి అప్పుడు ఇది ఎంత అవుతుంది? L by 2 root 2. Moment of inertia about common center of mass is 2 times. I know the moment of inertia of this system about this point. I know the moment of inertia about this point. What is that? 2 times ml square by 3. Correct? About this point, 2 times ml square by 3 is equal to ICM plus 2m times. Here you have 2m mass. Eight. ICM is ICM 5 by 12 ml square. Moment of inertia about the center of mass. At తర్వాత నాకు కావాలి కదా. Right. A collision happened. What is the initial angular momentum of the system? About the center of mass. There is no angular velocity part. It is simply m v by 2. By the way, what is this perpendicular distance? What is this perpendicular distance? L by 4. అంతేగా? అరే యార్, this distance is L by 4, this distance is L by 4. MV L by 4 plus L by 4. This is nothing but MV L by 4. Right. What is L final? Because you are doing the problem in C frame of reference. What is L final? Okay, ICM omega. Because you are doing the problem in C frame of reference. This is 5 by 12 ml square omega. So now, law of conservation of angular momentum about center of mass system. So this is MVL by 4 is 5 by 12 ml square omega. M cancel. L cancel. 3. This is one outstanding information. Right. So what is the final kinetic energy of the system? That's it. That is the final K. నాకు హెల్ప్ చేయండి ఒకసారి. హాఫ్ ఇంటూ ICM 5/12 ml square omega square half 2m. Velocity of center of mass is v/2, so v square by 4. ఇప్పుడే L ఒమేగా అంటే మీరు ఏదో చెప్పారుగా 5/24 ml అంటే 9/25 v square plus mv square by 4. Multiples 5 term, 3 3s, 3 8s. So 3/8 5 is 40. 3/40 v square plus 10 mv square by 40. 13/40 mv square. Hello, ఇది final KE. Initial KE half mv square. So loss is half mv square minus 13/40 mv square. 7/40 mv square. That's all. I got the answer. 7/40 mv square. I didn't do anything differently. I have done the same question almost in the same way what you are expecting. Any doubts in this? Are we clear? So maximum models I have covered actually from my end. This is a repeated question because just now I have covered. No, this is a previous IIT question. Previous IIT question is a fixed axis system. Now please go through this. Rod of mass m and length L pivoted at one of its ends is hanging vertically. A bullet of the same mass moving at speed v strikes the rod horizontally at a distance x from its pivoted end and gets embedded in it. The combined system now rotates with angular speed omega about the pivot. The maximum angular speed omega m is achieved for, okay. First of all, this is a fixed axis system. So you cannot conserve linear momentum. And you said embedded into the rod, actually. So therefore, angular momentum initial is angular momentum final, which you can write it as mvx. Initially, rod of mass ml square by 3 plus mx square. This is the moment of inertia of the system finally into omega. Now omega term contains mvx by ml square by 3 plus mx square. So therefore, A option is correct. Omega is a function of x. So you want a condition d omega by dx is equal to 0. So for this, differentiation of x is 1. Minus denominator differentiation into x. Zero. So practically, ml square by 3 is mx square. So x is plus or minus L by root 3. So C is correct. Minus కుదరదు కాబట్టి ప్లస్ తీసుకుంటాం. So therefore, omega max is mv L by root 3 divided by ml square by 3 plus mx square. ml square by 3. So this will now become M cancel, L cancel. So V by 2L times root 3. This is a previous IIT question. A very easy question actually. Any doubts? Right. I'll try to discuss some of the questions again. This is the one which I'm missing. This will be the last question for the day. Make sure you try this. Well, uniform stick AB has a length L. It is tossed up. Tossed up. Which means like a coin, you know. Like a coin, you toss it up. So, please try to understand. This is an old question. Usually, I will teach this question every year. Because this is some 2 years old, 2 years back notes which I have posted here. See, this is the same question given in 2023. There you have tossed a rod, here you have tossed a disc. Uniform stick AB has a length L. It is tossed up from horizontal position such that its center receives a velocity U is equal to pi root GL in vertically upward direction, and the stick gets an angular velocity. The stick lands back to its point of projection in horizontal position. During this course of flight, its angular velocity remained constant and the stick made one complete rotation. Stick rotates in vertical plane. First of all, you have projected this with speed u. So the total time of flight t is 2u by g. One complete rotation means the total angle covered is 2 pi for one complete rotation. Right. Omega times t is 2 pi. Omega into t. T is 2u by g. Is 2 pi. So with this, I can say omega is g by u. G by u. Right. Hold on. Equation 1. Omega is a pi term కూడా అక్కడ మిస్ అయింది. G into pi by u. But throughout the angular velocity remains constant. That's given in the question. Right. Now let me study what is happening. You have projected it. Next, stage 1. Stage 2. Stage 3. Okay. See, remember, try to please understand the angular velocity part. The time taken for the time taken for ఇదేంటిది
closure.
what is that? Your date and
20 days.
Right. So now the time part. Please tell me the time part. The time part is 1/2 of the time period. అంతేగా? Hello. Omega means G pi by U. One point that you need to understand in this point is by the time అంతే కదా ఇప్పుడు మీరు ఇక్కడ నోటీస్ చేయాల్సింది 1/4 of the rotation. It is a less than time of ascent. That is the first observation one should make. అప్పుడు ఏమవుతుంది నెక్స్ట్ ఇదే రొటేషన్ ఏమో తిరుగుతూనే ఉంటుంది ఇట్లా. ఆ తర్వాత ఏమవుతుంది నెక్స్ట్ స్టేజ్ B. That is the next stage. That's the next stage. So this is how it goes. See, by the time it completes half rotation, so 2 times of this. This is U by G. So half rotation, exactly it will become flat. And thereafter what happens? Till here it reached. Thereafter what happens? From here again, this will start. The center of mass will start moving down, but B will go up now. Still above this level you will have B. That is what you need to notice. Now what I need to study with respect to center of rod, comma, position of B. What is position of B? We will take so we will define something like this. Let this be theta. In that case, this is L by 2. And this distance is L by 2 cos theta. Hey, L by 2 sin theta, not cos theta, sin theta. So velocity of B with respect to center of mass, the 2y component is, this is omega L by 2, and you want this component. This is a theta, 90 minus theta, and this will become theta. So omega L by 2 cos theta. So velocity of B is omega L by 2 cos theta minus zt. Why? You know, from this point of time, you took t is equal to 0. This is the time when t is taken as 0. It's a freely falling now. So it will have zt velocity downwards. So what do you want? You want the instants when VB is equal to 0. What you will have in this situation is zt is omega L by 2 cos theta. G into omega already we know. Where we know is ఒక్కసారి నన్ను కరెక్ట్గా చేయనివ్వండి. ఇది theta 2 pi time is required. Omega into t 2 pi correct. Omega times 2u by g 2 pi correct. Omega correct. Correct. So therefore what I need to do is gt is omega. Omega ante g pi by u. యూని ఏమని రాసుకోవచ్చు? ఓకే, తర్వాత రాద్దాంలే. ఒమేగా కెన్ ఆల్సో బి రిటర్న్ యాజ్ హైట్ ఏమైనా ఇచ్చాడా? ఓ గాట్, యూ వాల్యూ ఇచ్చాడు ఇక్కడ. యూ వాల్యూ ఇచ్చాడు. సో ఒమేగా ఈస్ జీ పై బై పై రూట్ జిఎల్. జీ బై ఎల్. ఇంకెందుకు ఇది? theta is equal to omega t కదా. దట్ ఇస్ ద కండిషన్. ఈ కండిషన్ వచ్చింది మీకు అంటే కాస్ రూట్ జీ బై ఎల్ టైమ్స్ టీ is ఇది ఎంత రావాల్సి వస్తుంది మొత్తం అంతా జాగ్రత్తగా చదివితే 2 ఇది రూట్ జిఎల్ అంతేగా ఇది వచ్చింది. దీని ఏంటి? కాస్ థీటా ఈజ్ ఈక్వల్ టు 2 theta కండిషన్. అంతేగా, కాస్ థీటా ఈజ్ ఈక్వల్ టు 2 theta కండిషన్. దాన్ని సాల్వ్ చేయాలి. ఇప్పుడు మీరు ఎలా సాల్వ్ చేస్తారు? కాస్ రూట్ జీ బై ఎల్ టీ ఈజ్ ఈక్వల్ టు 2 theta అంటే కాస్ థీటా ఈజ్ ఈక్వల్ టు, అంతే కదా అక్కడ కండిషన్. దాని అంతే కదా. కాస్ ఎక్స్ ఈజ్ ఈక్వల్ టు 2x అయితే ఎక్స్ 0.45 అంటే అది ఏమి ఇచ్చినట్టు మనకి? రూట్ ఓవర్ జీ బై ఎల్ టీ ఈజ్ ఈక్వల్ టు 0.45 implies t is 0.45 root L by G. Done. What do you want? Omega. Calculate the maximum height above the point of projection to which the end B of the rod rises. ఆ టైం సబ్స్టిట్యూట్ చేస్తే మీకేమో అంటే మీకు ఇంకా అవ్వాలా ఆన్సర్. వాట్ ఈజ్ యువర్ రిక్వైర్మెంట్? యువర్ రిక్వైర్మెంట్ is HB is H minus a half GT square. Why? Because this is a H. And center of mass have moved down by half ZT square. With respect to center of mass, L by 2 sin theta. అదే కదా ఇచ్చింది. నేను అర్థమైందా ఇది ఎలా చేశాను? హెచ్ మైనస్ అంటే దీని రిఫరెన్స్ తీసుకున్నా, ఇది ప్లస్ L by 2 sin theta. సో సాల్వ్ చేస్తే మీకు కావాల్సిన ఆన్సర్ వస్తుంది. హెచ్ అంటే 1/GT 1/8 GT square minus half ZT square plus L by 2 sin theta. ఇది మీరు సాల్వ్ చేసుకుంటే నియర్లీ మీకు 5.04 ఎల్ ఈజ్ వాట్ యు విల్ గెట్. వెరీ వెరీ గుడ్ క్వశ్చన్ దిస్ వన్. ఓకే, so that's all for today. What I'll try to do is I'll post this notes now only.